Okay, so this is the anatomy of a secure Java web app using Apache Fortress. And for the next half an hour, we're going to think about how we should be securing web apps if we removed all stops. I don't think we need to do introductions again, do we?
No, I think we just did it. Although I will say one thing. I think every talk deserves a raise of hands. When you sign up for this conference, one of the things you fill out is whether you're on the builder side of things or solution or whatever. How many, just show of hands of those that are on the building enterprise application side of things, so builder side of things. Okay, cool.
Cool. Okay, so we're going to have a look at Equifax and the software breach that happened last year in order to set the stage to provide the rationale for what follows. And then we're going to have a look at a couple of examples under the Apache Fortress. And we are going to talk about role-based access control and how it can be improved by putting a little bit of A back in there. I do have a recommendation. There's going to be a bunch of slides, there's a bunch of links, there's a ton of artifacts that are going to be represented. And if you try to take notes, it's probably going to be a little overwhelming. So those slides are published on that link right there. I encourage you to just try to listen and absorb these concepts conceptually. All right, so what's the problem? This is 2018. Why are we still talking about application security and the problems with it? Haven't we figured this out? And from a technology perspective, I'd say, yeah, we probably have. But from a practice standpoint, maybe not. And so the events that happened at Equifax last year bring this to the forefront. And I suspect, since this is AppSec, everybody's heard of what happened at Equifax, right? And certainly, probably everybody in this room had their personal information exposed through that breach, which is very unfortunate. And what we found out was really, in the case of Equifax, only a veneer of security was in place. So what happened at Equifax specifically? And it's this CVE 2017-5638. And that's a vulnerability in Apache Struts, which is an open source web application framework that's quite popular. What happened specifically was the attacker was able to upload a string of data inside of an HTTP header and trick the server into executing it as a system command. How did it do that? Within Struts is a library called the Object Graph Navigation Language, which is a common avenue for exploits right now for remote code execution. Basically what happens is what is being shown there on the bottom, where the attacker is able to upload a string which is then executed on the server as a system command. And so once that happens, it's game over. You've lost. So if you're interested in that exploit, I encourage you to look at this webcast by Black Duck. It's going to tell you everything you need to know. But we can get some useful information by looking at the statement that was made on the Apache Software Foundation blog by the Apache Struts team, specifically Renee Gielen. And he had a number of things that I think is worth pointing out. So this number 2 is establish a process to quickly roll out a security fix release of your software once you find that there's a problem in security. And basically, what he says is most breaches we become aware of are caused by failure to update software components that are known to be vulnerable for months or even years. And indeed, that was the case at Equifax. So CVE 5638 was detected out in the wild in March of 2017 and was promptly patched by the Struts team. However, Equifax chose not to apply that patch. Had they applied that patch, that breach would not have occurred. So that we know. So what Renee's saying there is very true. It's just apply patches. So the solution then is we should just ensure all appropriate patches have been applied and then we're okay, right? And we're at OWASP conference and there's OWASP provides a tool that can help you do that. They've got a dependency check mechanism that works on several platforms. And basically what it does is it compares your project's dependencies to the list of known vulnerable libraries in an IST database. And if it detects a match, it will spit out a report. You apply the patch, and off you go. So this is what I did with my project, which is Apache Fortress. It's a Java application. It uses Maven, so I just dropped a Maven plugin into the POM file, and I run this. I execute the scan before release, and if there's any vulnerable libraries in there, like say if I was using Apache struts, which I'm not, but just say I was, it would find it and spit it out to you. Wonderful. So let's go back to the Apache strut statement. Number 3, any complex software contains flaws. Don't build your security policy on the assumption that supporting software products are flawless, especially in terms of security vulnerabilities. Okay, now what? So how do we secure our software from unknown vulnerabilities? So it's not like there's going to be a tool that's going to be able to scan your software and say, hey, you have an unknown vulnerability. That's never going to happen. That's impossible. I would assert to you that the list of unknown vulnerabilities is larger than the list of known vulnerabilities. Back to my statement, I've made a pretty good living writing bad software. There's a lot of us that have made a pretty good living writing bad software, and there's a lot of bad software out there. So what do we do about it? All right, let's try this again. We're all security practitioners, so we have a number of principles that we use to help us guide us through our job. And a well-known principle is called the principle of least privilege. What does that mean? So like when you're running Apache web server in production, you don't run it as root, right? Why not? Because you're exposing that process to files and folders that it doesn't need to do for its job. So you're going to run it as a non-privileged user that only has access to what it needs to do. That's a very simple example of practicing the principle of least privilege. But that's not far enough. In the case of Equifax, they were running Tomcat underneath a process that was not root. And still the attacker was able to be exposed to the system. So there's more granularity there. So this is a Java Web Security talk. And one of the tools that we have as Java Web Security practitioners is the Java Security Manager. Now, how many here are using Java? How many here use the Java Security Manager? I see one hand. Why is that? Okay, it's been around since the beginning. And the reason is it's kind of hard to use. But nevertheless, it provides a very powerful mechanism to practice the principle of least privilege. How does it work? As soon as you turn it on, everything's off by default. So back to Equifax, if you have some unknown attack vector where the process is going to shell out to the system, it's not going to get past the Java Security Manager unless you explicitly give it a permission like this to say, oh yeah, I'm going to let applications execute from my web application, which you're probably not going to do. So had Equifax applied the Java Security Manager, even if they were vulnerable to that CVE 5638, that breach would not have occurred. So if you're interested in how you can exploit the Java Security Manager to protect you, I have an example in my GitHub account behind that link that shows you a couple scenarios that you can use. The reason why one person raised their hand is that it's not a perfect solution, okay? It's hard to get to work, and it has some caveats. One of which is if you use reflection in your application, then you have to add this declarative right here to suppress access checks. So you've just opened another hole in your application. So it's not perfect. However, I will say that if you at least run your application under the Java Security Manager, you'll learn a lot about your app. You'll learn a lot about what it's doing. You might find some things that you didn't even know that it's doing, and that will give you insight into how to protect your application. Okay, so now what? Let's go back to what Renee said. Number 4, establish security layers. It's good software engineering practice to have individually secured layers behind a public-facing presentation layer, such as Apache Struts Framework. A breach in the presentation layer should never empower access to significant or even all back-end information resources. So we're back into our security practitioners, into some principles that we can apply. And this one is defense in depth. The building up, layering, and overlapping of security measures. In contrast to a metal chain, which is only as strong as its weakest link, the defense in depth aims at a structure where should one defensive measure fail, other measures will continue to provide protection. So that's where you get this onion, where the network surrounds the host, surrounds the application, surrounds the data. So in the Equifax situation, the application was breached, and they had no protection of the data. They weren't practicing defense in depth. Okay, so this is a Java web security talk. These are the layers that I've identified that are available to us as security practitioners when we decide where we want to apply our controls at. Would you apply controls in all of these layers? No, probably not. But you should at least be aware of those layers and know what they're good for. Speaking of, what are they good for? They all have, all these layers, they don't all do the same thing. So we already talked about the Java SE security, that's the principal of least privilege, that's for applying mandatory access controls. You have the Java Secure Socket Extension, JSSE, and that's for encryption and integrity. Java EE security, that's the deadbolt on the front door. Fail-safe mechanism on your application. Spring security is a Swiss Army knife for Java security. It does a lot, but for here in this talk, we're talking about doing page-level security, which is, back to our building analogy, you can get in the front door, what rooms can you get into? Web app framework, you can get in the room, what equipment can you operate once you're in the room? You've got buttons, you've got list box, things like that. How do you control it? The web app framework is the layer in which you do that. The database, that's where you control the content. So you can operate that control. What data can you operate on? What can you look at? What can you do to it while you're there? All these layers work together. So again, you wouldn't need to do security in all these layers, probably. It'd depend on your requirements, what kind of application you have. If you were a health provider and you had perhaps patient information inside of a database that was subjected to HIPAA requirements, you'd probably want to be thinking about beefing up that layer right there. So it all just depends on your requirements. Okay, so this is all in setup of this example that we put together for you called the Apache Fortress demo. And this is a sample business application that applies security inside of all these layers. We're not going to talk about how to install it or how it works today. We're just going to actually look at these layers and talk about what it's doing inside those layers, and we're going to do a demo. But if you want to try it out, you can follow the link there. All the instructions are there. All of the installation instructions, everything's open source. So I encourage you to take a look at it. Okay, so we're looking at the layers and what we're doing in the layers. So again, we've got the Java EE security, that's going to be the outer perimeter. That's the deadbolt, okay? And this security system has to, it has to be able to be installed. You have to have what I call a policy decision point, okay? And so I'm talking about this as if it exists, but we haven't even defined it yet. And so what we're talking about here in this example is setting up a role-based access control policy decision point. What's role-based access control, John?
Let me show you how it's done. All right, so maybe just a little bit of backdrop about how Sean and I met up maybe about a year and a half ago. So Sean is on the, he's on the open source, solutions side of things. We're going to be hearing about Fortress throughout this, and I've used Fortress. I'm on the application side of things, so the builder side of things. And so maybe just a little bit of context about what my perspective is and how it is that we met up. So I'm an enterprise application guy. Lots of security. Security's been in my in my career from the beginning. Probably lots of it because of payments and financial services and things like that. We all are. These days in an enterprise, you're building an application. You got to know about the security aspects. And so one thing when it comes to the authentication and authorization aspects of how you put that inside of your application and how it's done inside of your enterprise. Authentication, is kind of a great place these days because there's standards. Identity management has been, common identity management with common interfaces like SSO and OAuth and SAML. It's all there. So you can be in an enterprise and the authentication side of things or auth-end side of things, it's solved. We've come far enough where that's solved for you, for the most part. On the authorization side of things, on the role-based access control side of things, in my experience, it's not there. The standards aren't there, and you end up in an enterprise with lots of RBACs. They're all over the place. You got an RBAC that you're going to build probably multiple times. In a big enterprise, different teams are going to build it over and over again, and then you've got all the RBACs that come with the little middleware that you have, and then you've got to synchronize all of them. If you're on the builder side of things, you know this problem, and it's a pain. But you can't control all of that, but every once in a while, just before I'm about to go, the project about a year and a half ago, just before I'm about to build RBAC yet again, I go and check to see has anything happened. Is there a solution out there for me? And I found one. So this was about like I said, about a year and a half ago. And it started out on the NIST website, looking for RBAC, finding if you've ever chased these links down, you go and you find a paper that was written in 1992. I'll talk about the kind of the history of it in just a little bit, and then finally you'll see what it is that is an ANSI specification. We'll be talking about that. So the ANSI specification got me very excited because then it was, if you look at the, we'll be going into this model, we'll be going into the kind of the details of this model in just a couple of slides, but it's very flexible. It has, as it hits your eyes, it's got all the things that you would have invented anyways, right? It's got users and roles and permissions, which are a combination of a object and an operation, and you're like, okay, cool, I need that. And I'd like to not build it again. And I'd also like to I'd like to just leverage a whole bunch of thinking that was done out there so that I don't have to go and defend it again. Because when you're faced with the security guys in enterprise, then you're inventing something, and it's just why do that? Especially when the application you're building is about something totally different, like payments. So why are you spending time here? So there is a specification out there. That's the ANSI specification. Someone like Sean is all over that. And it's got a whole bunch of, you might call this a maturity model. There's different levels, 0 through 3. You can mix and match and use any parts of them that you want. A little bit about the history of it. So I talked about, just if you kind of go navigate this, you're going to find a couple of things that were, like this paper right here, which was done in '92, and this other one in 2000, and it's got pieces of that model in it. But I can tell you that is a very dry read, incredibly dry read. So by the time they took it and turned it into an ANSI standard over here, it's very readable, and it's very, yes, I want that. So what it is, just to kind of walk you through this, we won't go through it in great detail, but just a couple of things like some of the acronyms on it, like DSD and SSD. So first of all, the easy part. The idea that you have a user, of course. The idea that you have a role, of course. As far as how you take those roles and assign them to permissions, they have a couple of constructs. They have a permission, which is composed of an object and an operation. You get to create this model. So it's just a framework. You get to create the taxonomy of your model. In your RBAC data, you have the model part where you set that up ahead of time and say what your objects and your permissions and roles are. And then you have your instance data where you're actually populating users and assigning them to roles. And so that part right there, very straightforward. You would have done that anyways. And actually, the rest of the model is very straightforward as well. Role hierarchy, you probably would have done that as well. Some people need it, some people don't. There's also group capability as well. But it has role hierarchy built in. So that's great. You need that in the model. SSD and DSD, they stand for static separation of duty and dynamic separation of duty. Concepts are really easy, and probably something that from a separation of duty and security and compliance, that your compliance guys want that anyways. And so static separation of duty is simple. It just means that statically in your model, a person cannot have this role and that role. That's all it is. So when you go and define your taxonomy, you can set up that so that no matter where you try to come in through the APIs and try to assign these two roles to the same person, you're not allowed to do so. Dynamic separation of duty kind of goes hand in glove with the session concept. And the session concept is, it's like a login concept. You can choose to use it or you can hide it if you want. You can attach it to your login concept. And DSD is what that says is, okay, fine, you as a user can be this role and that role. You just can't be this role and that role at the same time in the same login session. So that's the context behind that. As far as we kind of already went through these, but as far as the object, the session, again, you can correlate that to a login session, and then the triplet, if you will, of the object, operation, and permission, you get to create that taxonomy any way you want. Very flexible model. All right, so far we just talked about the model, and that's great, and there's a standard for it. I hope at some point, because I really, really want to stop building RBAC systems, that that it'll catch on, and in an enterprise that it'll be the same kind of thing that you can just like SSO and SAML and OAuth is, that everybody can be speaking the same RBAC. I would love that to happen, but I can't control that in the world, but certainly inside of any given enterprise I can kind of push for this and not write them myself. So Fortress, Apache Fortress, that's Sean's area, that is an implementation of this. This is how we hooked up. I was looking for it once again. That scene in Indiana Jones where I'm about to write RBAC and the face is melting like, oh my God, I don't want to do that again. That was happening to me. I found this, did some blog stuff about what about this and what about that, and then it just fell in my lap. It's one of those things you download it, you start using the API, and you go, that. Well, that's what I want. So Fortress is an implementation of the standard. It's got all the APIs and they're all very intuitive, broken up into administrative and so on. You can populate your model ahead of time. You make up what your objects and your operations and all of those things are. Then you can populate your instance data, your users, and all of that. And you got all the CRUD APIs across that entire model that you would expect. Everything's audited. It kind of all comes down to, at the end of the day, check access. In your application where you're supposed to pepper and make sure that you are controlling, and you can put it anywhere. It's totally API. It's not one of those architectures that takes over your architecture. It's an API and a solution and a server that allows you to go and put RBAC controls anywhere you want them. You can put them all the way from your APIs, through your UIs, down through your data tiers. Well thought out API on top of a well thought out standard, and that's kind of where we met. I would say about maybe a year and a half ago. So with that framing, I'll go ahead and hand it back to Sean, and we'll get down into the weeds in some of this.
Okay, so if you're interested in RBAC and how you can instrument your application to use it, and I call that process role engineering, there's another sample here that we're not going to go over that is designed for that. So I encourage you to check that out if that's something that you find interesting. Okay, back to our layers. We're now halfway in. We want to put the locks on the room doors. Okay, so we're going to use Spring Security, and we're going to establish a mapping between a role and a page. To say to hit page 1, you got to have role 1. To hit page 2, you got to have role 2. Now we're in the web app. Now we got to get the programmers involved. Okay, so this is the controls on the page, and basically what we're talking about in this application, which is an Apache Wicket web app, is secure components, secure buttons, secure links, things like that. So those are instrumented via the programmer. Finally, down in the lowest layer, we got the database. This sample application is using MyBetas, which is a very simple object relational framework. This technique would work with any of the OR mapping facilities, but basically we're instrumenting the DAO in this app with more programmatic checks. So you might ask, well, why do I have a programmatic authorization check in the database and in the web app? Wouldn't one or the other suffice? Well, what if the attacker was able to bypass the web app framework like what happened in Equifax? What then? What if they are able to instantiate your DAO component using reflection? Do you have any protection for that? So that's where the defense in depth comes in. One layer breaks down, the other one picks up the slack. Okay, this is 2018. We're gonna encrypt everything, every remote connection, TLS. That, I don't even think that's up for argument anymore. So this application shows you how to, and I'm sure we all know how to do that, but in case you want to try it out, this will show you how to set up the keys and the certificates and do all the things that you have to do to have every one of these connections encrypted. Okay, so we're going to do a real quick look at this demo because we want to look at an RBAC policy, like what John was talking about. And so we got a simple web application, like we said, where there's 3 pages and there's business data. And the business corresponds with 3 customers, customer 1, 2, 3, 4, 5, 6, and 7, 8, 9. So what I've done is I've established a fine-grained authorization policy where every page has a customer relationship. So if you want to hit page 1 for customer 1, 2, 3, you have to activate that role. Okay, so there's 3 pages, 3 customers, there's 9 application roles, and furthermore, we set up a dynamic separation of duty constraint to say one and only one of those roles may be active in the session at a time. Okay, so we're able to do things like this, where we can very fine-grained control what pages customer combination can be accessed via the security system. So we, a customer like, or this user here, user 1, 2, 3, that has access to all pages for a single customer, or user 1 that has access for a single page, all customers, or user 1, 1, 2, 3 has access to a single page, single customer. So we'll just look real quick at how that would work. I'm going to log on to this application that's running locally. And so I hit the URL, and the container, in this case Tomcat, is challenging me with a login. So this is Java EE security. So I log in, the container lets me through. Now I get a landing page where you can see the web app framework is aware of the policy. It's presented me links to the 3 pages. I go to a page and there's no buttons there. Why not? Because I haven't activated a role yet. So if I activate a role in this case, page 1, 1, 2, 3, then the buttons pop up. Those buttons are aware of the policy. And now I can interrogate that data, say 1, 2, 3, and it will come back in the list box. So what if I change it to another customer for a role for which that wasn't activated? I think you can guess what happens. You're going to get an authorization error because that data, so that it's, they're violating the policy. So let's just activate the role for page 2, 1, 2, 3. And I activate and I get another error, which is a dynamic separation of duty constraint violation because I'm trying to activate 2 of those roles in my session at one time. So before I can activate the second role, I've got to deactivate the first role, and then I can activate the second role and then operate on that data on the second page like we did before. Okay, so you can see that that's pretty straightforward. So before we leave this app, I just want to show you one more scenario with this user 1 that has access to a single page, all customers. So let's log in as that user. Say, okay, there again, the web app framework presents the user with just a single link this time. I click on it, same scenario, we're not going to run through all that again of activating the roles, but what I wanted to show you here is if this user elects to bypass the link and just enter the URL to the second page, Spring's going to catch it. Okay, so that's kind of an example of how defense in depth works, is that all these different layers are working in concert together. Okay, so back to the presentation. Testing is important. I once worked with a team that had a web page where you could log in and all you had to do was enter a valid user ID and it didn't check the password. And that bug was in place for a number of years. So if you entered a password, it would check it, but if you didn't enter a password, it just let you in. So you want to have automated testing. Inside of this app, we have this Selenium that shows positive, negative test cases on that. So that's part of this sample.
So if this is the lots of spirited conversations with Sean over time. This is you go and look at the model that we talked about before, and it's a good model, but by itself it's broken when you go to actually apply it. And where it's broken, if you've done RBAC implementations before, or populations of RBAC implementations, the models of them, you run into, if it's not flexible enough and smart enough to be able to deal with this, that simple model in multi-context types of RBACs, where you want to be able to say, that this user is associated to, is assigned to this role, but only within this context. And maybe that context is like a customer. So this user is a dishwasher for this customer, but is a cashier for this customer. And very quickly, if you're working with an RBAC model that isn't flexible enough, you're going to end up with teller or washer 1, washer 2, washer 3, a whole bunch of roles that are really saying the same thing, but because you had to go and solve the context problem, you end up with role explosion. And so the model by itself, and basically just very quickly what it does is it just says that it forces you into a place where you have a whole bunch of roles, and then it's very difficult to manage these. So if you allow yourself to split up your roles, and really you only have one definition of a role, it's a dishwasher, and here's all the things that a dishwasher can do. But because you have different contexts, you're forced into creating a whole bunch of them, and now you've got to administer all of them. Synchronization, all the things that go along with that. And that includes the administration on the power user sides. Okay, it's a problem. Well, as it turns out, and again, this is why I'm glad people like Sean are around to, the RBAC specification has a solution for this. There's, in that model that we looked at before, there's constraints that you can freely use throughout the model. And you can apply it to help you solve this problem, which we did. And it totally, alleviates the role explosion model. So the last time we looked at this model, this is, right, it's between user and roles, but there's nothing in there that helps you with I want to say that this user can be this role within this context for this customer, let's say. And so that by itself doesn't allow it. That's the broken part of that model. But with constraints, which is part of the specification, and Apache Fortress supports it, you can do exactly that. And so the role constraint, it allows you in your model to specify that here are the rules for this customer. This customer must, or I should say, this role must be accompanied by a customer specifier when applied to a user. And now you have what you need with just that little thing. You have what you need to make it so that your roles don't explode. You have one cashier. And with that one cashier, which you don't have to multiply or do multiple times, you can say that Mo is a cashier at in and out. It's scoped. And because I populated that way, I can't create a session or I can't do check access on Mo as a cashier at McDonald's. Seems subtle, but if you've been through RBAC implementations before, this invariably is probably happened to you. You need a robust model to be able to, and solution to be able to get past that. So, a crucial part here, or takeaway, is that the model, the simple model, is for simple use cases. I don't think any of us have those. You need something that allows you to do constraints like that. And then, of course, through your power users and whatnot, it's all the same. Okay, so I'm gonna hand back to Sean to take a look under the
cover. How much
cover.
time do we got left? 2 minutes?
Yeah.
Okay. All right, so we don't have time to look under the hood. So the problem, this role explosion problem that John just told you about has been demonstrated. I demonstrated that to you before on the previous app. That's basically was an implementation of a role explosion where we had fine-grained roles, too many roles. It works with 3 customers. What if you had 50,000 customers? Are you going to have 150,000 roles? So the fix to that, which he just talked about, which is the role constraints, is part of this sample right here, the Apache Fortress ABAC demo. We'll show you how it works if you want to try it out. We don't really have time for the demo. We're out of time. But if you catch me in the halls afterwards, I'll show you. Closing thoughts?
I would say if you're on the builder side of things, call to action. If you haven't looked at, if you're coming around the corner to a project and you got application RBAC solution that you need to come up with, take a look at Apache Fortress. You don't have to go there and build that again. It's like you don't have to do that thing where step 1 to building this payment application I have is to start writing an operating system. You don't need to be there, and this
unless you want to build one.
Unless you want to build one.
It took me about 5 years.
Yeah,
so
that's all right.
All right, so the examples are all here that we went over. There's a couple bonus ones on the bottom. There's one that shows how to combine role-based access control with a SAML endpoint. So those, I encourage you to check them out, and we support them. So if you have any problems, join the mailing list or whatever, and let us know, and we'll fix them. Okay, I don't think we have time for questions.
Thanks.
Thank you.
Right on, dude.
Good job, man.